This talk is brought to you by the Bamberg Mathematical Consciousness Science Initiative.
Well, hello everyone. Thanks for coming to my talk. Particular thanks to Johannes and Camilo. I think Johannes did a very brave thing when he decided that the first workshop in this whole what is it called? Mathematical phenomenology sprint?
Sprint, yeah, sprint.
So the first sprint is devoted to the topic of mathematical phenomenology, and I really like that. And I think it's a very brave thing to do. Of course, I think that it's very promising to talk about phenomenology, but I also understand that it's maybe not the most mainstream topic that one could choose. So I'm all the more kind of excited that this is the topic, and we already had some great talks yesterday, and I hope I can continue a little bit with that today. So today I will talk about what I call mathematized phenomenology as a transcendental interface to the world, and I will explain what I mean with these terms. Maybe just start with a brief outline. Yes. Okay. Rough outline in 5 parts. So we have a lot of stuff to cover, unfortunately. The time might be a bit too short, so I might need to skip here and there a few slides, but it's not a problem. So the talk is structured in 5 parts. First part is a bit foundational. It will involve a lot of repetition, stuff that you might have heard somewhere else, or maybe from my side. And then I will talk about the main stuff or the main content of this presentation, which is what I call a phenomenological double dissociation. So I will talk a little bit about the difference between structure and content. I will give one example, the integrated information theory. I think that's very well known. And then I will talk about the second part of this dissociation, the second leg, which is the difference between descriptive and transcendental approaches. That might be a little less known. So I will start to discuss this along some examples, very well-known examples from the phenomenological literature. Then there's a fourth part with transitional models, which connect this descriptive approach to a transcendental approach. I might be a bit shorter on that. And then in the end, the last part will be about transcendental analyses. So the stuff which I think is most interesting actually in phenomenology. And I will give first some examples, and then I will talk about some methodological issues at the end. Okay. Okay, let's start with the foundations. So it's always good to have a kind of preliminary definition, and in the end you might find that this definition is actually not a good one, but it's a good place to start anyway. So I would define phenomenology as the systematic, and the word systematic is very important, study of subjective experience. And in the context of mathematical phenomenology, the systematic just means mathematical. So one example would be to give a formal representation, meaning a mathematical model of the constitutive transcendental processes that shape experience. That's one example, which I like because it's one transcendental example. You might want to choose a different one, but just to give you an idea. But this definition needs to be finessed. I think there's a common misunderstanding about phenomenology, or what phenomenology actually is supposed to do. I think it connects very directly to a fundamental problem in consciousness science, and I think it's the most important problem in consciousness science, namely to relate third-personal data, measurement, for example, or reports, or behavioral readings, or whatever, to a first-person perspective. So phenomenology is not about or not limited to the description of subjective stuff that's going on, but it's really about mediation, or how I would put it, phenomenology describes an interface between subjective experience in there and stuff that happens in the world out there, so to speak. Now, with this definition in mind, one might ask, why should I actually do mathematical phenomenology? And I think that's an important question, because a lot of people have this sense that, well, consciousness is maybe the only thing which is not amenable to formalization. So if there is something in the world which shouldn't be formalized, it's consciousness. So why the heck are you doing mathematical phenomenology? And there is some truth to this, but there are a lot of things to say in response. I won't go through all of them. Here you just see 5 examples. I particularly like the fifth one the most, which is the problem of integration with science and technology, meaning that in our current time, especially in our current time, scientists and technologists, AI people, they will do whatever they will do. And when you're interested in phenomenology or when you're doing phenomenology, it's a very good idea to be able to communicate with them or to relate to their whatever they do. And I think that's already one very good reason to adopt a mathematical method or mathematical language. Okay. Next, I will discuss two very common conflations, and I think that has already been mentioned yesterday a couple of times. The conflation between phenomenology and phenomenology. So it used to be the case that some people actually use the big P for the philosophical study and the small p for the more, let's say, colloquial usage of phenomenology. It's often presented along a historical distinction, namely a distinction between a tradition, a philosophical tradition, which started with Husserl and some other people. Maybe scholarly important to say that there is no single tradition of phenomenology. There are many different schools of phenomenology, but they run something like a common red thread throughout these philosophical discussions. On the one hand. On the other hand, you have a tradition which is more coming from an empirical psychological angle. One of the founding fathers of that was William James. William James was a great philosopher, but many of the followers or many people who are doing empirical psychology now are not so keen on doing philosophy anymore. Now, this historical distinction is sometimes mentioned. So people say something like, oh, I'm not doing this Husserl stuff, or I'm not doing the psychology stuff, and so on. But behind that distinction, I think there's a more important systematic distinction. And the systematic distinction is the one between what one could call the a priori study of essential structures of subjective experience versus a posteriori study of contingent contents. Those of you who have a background in philosophy might have an idea what I mean with this. The others, don't worry. I try to give some examples and make that a little bit clearer what I mean. The second conflation, which should be mentioned in this context, is the conflation between mathematical phenomenology, which is an analytic or descriptive project, and the phenomenology of mathematics, which is a more foundational or historical project. So in the first, you try to use mathematical tools, mathematical structures to do phenomenology or to interpret phenomenology. And in the second project, you try to analyze mathematical concepts or mathematical tools as they are grounded in experience. So it's a foundational project. And two important things, one can do one without the other. So for example, one can just do mathematical phenomenology without being very knowledgeable or interested in the phenomenology of mathematics, or the other way around. So for example, when one does something which I call an anything goes approach to phenomenology, then one would say, okay, I don't really care. I take whatever mathematical method does the job, whatever is descriptively adequate, whatever works, and I do phenomenology with that. Or alternatively, one can say, okay, I try to keep track of both of those things. I use mathematics, which is grounded in consciousness, to do phenomenology. So one can say consciousness is studied by consciousness to reflect back on consciousness. And that gives it an interesting, let's say, self-referential twist. But I won't talk about that in my talk from now on. Instead, I will focus on, I already said that, what I call the double dissociation in mathematical phenomenology. And the double dissociation has two dimensions. So on the one hand, one can distinguish an approach which studies contents and an approach which studies structures of experience. And then in the second dimension, one can look for descriptions versus transcendental approaches. And you see here a little picture. I placed some prominent projects on the one hand in phenomenology and in consciousness science in this two-dimensional space. And I won't have time to talk about all of them, but at least I will talk about some of them. And the ones where I don't say anything about are the ones which I'm not really sure what to say. So that pertains, for example, to the whole, what I call the Paris neurophenomenology inspired school. I won't say anything about that. I also won't say much about what people nowadays refer to as computational phenomenology. But I will say about many other things. I will start with one in a moment, but first I just want to introduce this methodological claim that I have. It's a claim about methodological orthogonality, which just says that whether you're doing mathematics or computational modeling or empirical stuff or philosophical reasoning, doesn't really depend on where you can place yourself in this matrix. So whether you're on the top right corner or whether you're in the bottom left corner, that you could both do computational modeling studies. So I think there's a dissociation between the methodology and the characterization of the project in terms of phenomenology. Okay, now I start with the first leg of the dissociation because that's maybe a bit more well known, namely the distinction between a content and a structural approach. Now I think to pump some intuitions, it's quite helpful to list some paradigmatic questions that come with this content approach. So for example, when you ask, what is redness like? What is the redness of red? How intense is your experience? Do you see this or don't you see anything? So this yes or no question, this contrastive approach question. That's a typical content-related question. Another thing which is often related to a content of consciousness is the so-called unity of consciousness. It's a certain property that consciousness has or that conscious experiences share. Now it's important to note at this point already that these questions are often already questions about structure, or at least our best methods to answer these questions are structural. So you see that when you look in the literature about discussions of the unity of consciousness. A lot of people use structural tools or look at relations between experiences, between possible experiences, to say something about the unity of consciousness. And it brings me automatically to the second dimension, namely the dimension of structure. So typical question here would be, where in this space is some experience located? So in psychophysics or in quality space theory, you often do that. You have a certain space, a phenomenal space or a quality space, and then you locate a certain experience within that space. And you're asking, what are the coordinates for one experience to lie in that space? Or you might ask this question, why is a certain content perceived like this and not like that? It's basically asking for a relation between experiences, or a difference between this experience or that experience. It's also a structural way of asking this question. Or very differently, you might say something like, how is consciousness essentially tied to perspective, to this notion of perspective, taking a perspective? One of the models that I might discuss today, the projective consciousness model, is actually very closely related to that question. So you see here two quotes, which I think are paradigmatic for the structural approach. Both papers define this idea, what is a structure, or what is a structural question, what is a structural fact about experience, more thoroughly than just going for this intuition. So one paper is by Johannes, and another paper is by Andrew Lee, who will also give a talk tonight. So I refer to that work. Now I want to further pump your intuition, discuss one example, namely the example of integrated information theory. IIT, I think, is very interesting in many senses, in particular in that sense that IIT is often, people are often referring to IIT as a paradigmatic example of a structural approach. And I think that's not quite true, actually. I think IIT is an example of a content-based approach. And here's what I mean by that. If you look at this quote, it's from the latest iteration of IIT, Integrated Information Theory 4.0. Authors write that IIT proceeds by considering whether experience, phenomenal existence, has some axiomatic or essential properties. Properties that are immediately and irrefutably true of every conceivable experience, drawing on introspection. That's another motive which is often mentioned, and you talked about introspection yesterday, and reason. IIT identifies the following five, and then there come the essential properties of consciousness. Now, the way how these essential features of consciousness are spelled out in IIT is then in terms of a structure of causal informational processes in neural or physical systems. So when IIT refers to structure, then don't necessarily talk about the structures of experience or structures between parts or aspects of experience, but it's mainly about structures of these physical things. However, there are some approaches in IIT or in the vicinity of IIT that move closer towards a structural approach. So, for example, there's some work about why space feels the way it does, which is about inclusion relations of parts of experiences. So spatial experience is just that experience which satisfies certain relations. Or the bit newer, the qualia structure approach from now to Gia could also be characterized as a structural approach which is based on IIT. So IIT, as a start, I would say, is not purely structural. So it's not the best example for a purely structural approach in consciousness studies. I will give you another one, a bit later one. But yeah, before I do that, I will come to the second leg of the dissociation, which is the distinction between description and transcendental approaches. So here I don't proceed with typical questions, but with typical motives that you will find in such studies. For example, if you read some phenomenology, you often encounter this term, the natural attitude, which means that we take the existence of an external world, which may be a physical external world, for granted. And people who do what I call descriptive approaches often do that. They say, oh, consciousness, that there's this external world and there are objects that move around, that behave somehow, and consciousness is some event that happens inside one of those objects. Often, for example, people refer to introspection as a kind of inner perception where you look inside those processes that happen in these objects. Or people talk about subjective reports and the necessity to make inferences based on those reports. Or in psychophysics experiments, people talk about button pressings or about relations that they infer from those data. Nothing is wrong with button pressing. I like button pressing, but sometimes those studies read as if that's actually all there is to consciousness. And I think that would be a mistake to limit it to that. Or more sophisticated and descriptive approaches might work with neuronal imaging or with decoding experiments where you try to get to the content of a conscious experience via encoding some patterns of neural activations. By contrast, there are transcendental approaches and typical motives of these approaches. On the one hand, bracketing, suspending the belief in the existence of an external world out there, or provocatively put, one could say the world is a phenomenon in consciousness, it's not the other way around. A typical motive here would be to study modality. Here modality doesn't mean sensory modality, so it's not vision or audio or whatever, but it refers to a certain kind of necessity or a certain way how experiences follow each other. We'll give you an example in a minute. Then there are various traditional phenomenological themes, the epoche, constitution, time consciousness. In this context, the epoche is often discussed. I won't discuss the epoche. I will say a little bit about time consciousness because I think that a lot of people mistakenly would say that time consciousness is a paradigmatic descriptive notion. I think it's a transcendental one. Of course, description, it also includes a description, but one would miss this importance of time consciousness for phenomenology if one would limit that to a purely descriptive approach, in the sense just outlined. Another motive that you find in transcendental analysis is the relation between actual and possible instances of experiences. So, for example, when you think that experience, the way how we consciously experience something right now, depends or supervenes on a set of relations between possible instances of experiences. That's a very transcendental way of thinking about things. And the last motive I called constitutive constraints. I will talk a little bit more about what I mean specifically with that. So the idea is that phenomenology prescribes certain constraints that we need to keep in mind when we want to understand the arising or the genesis of intentional conscious experience. Okay, again, maybe it's best to discuss some examples. One example for modality is actually from mathematics, and it's not a typical phenomenological example, it's actually a mathematical example, but since we do mathematical phenomenology, I think it makes much sense to discuss that example, and that's the example of a triangle. So we all know, we learned that in high school, that the sums of angles in a triangle is 180 degrees. Now, from a more philosophical perspective, one would say something like that it's a necessary statement or maybe even an a priori statement. It's not an empirical generalization. So you don't go out into the world and you look for triangles and then you see many, many, many triangles and then you say, ah, that shows me that the angular sum is 180 degrees. That's not how it works. So in that sense, phenomenology is actually very close to the method of mathematics. Phenomenology doesn't know and does not only deal with what one could formal essences, which mathematicians are interested in, but also with something which phenomenologists call material essences. But that's a finer distinction of the literature. Now, Husserl was very interesting, I think, in that he gave this whole discussion a new twist, somewhat of a new twist. So already these discussions with triangles, you already find it in Immanuel Kant's work about transcendental philosophy. He made a big deal out of that. Now, Husserl added several important things, but one of the things that he added was to say that truth is framework relative, or as Husserl would say it, essences are regional. By that he meant it really there is not only a formal, eternal, singular concept that you have to look at, but there are various different forms of essences, meaning properties which define how objects can be constituted in experience. And a very, let's say, illustrative example from mathematics again would be what happens when we look at triangles not in flat space but in a curved space, and the law might be very different. And in some sense, that's related to what Husserl would say when he says something like essences are regional. An example which is a bit more related to phenomenology itself or to psychology is actually something which you heard about yesterday, which is about the essence of visual perception. So vision, when we see an object, we strictly speaking see or experience actually more than what we would record with our senses. Meaning there's the difference between the house that I have in my experience, the content of my experience, and the actual perspective, which is what we would record with our senses. So the essence of visual perception on that picture would be that it's only presented to us in a perspectival form. We always see perspectives, and the task of the phenomenologist would be to say how are those perspectives lawfully or regularly related to each other. Or as the slogan, we see a bit more than what hits our eyes. And the final example for classical transcendental phenomenological analysis, I already hinted at that. It's time consciousness. Here you see a kind of cartoon of the Husserlian model of time consciousness, which consists of three things. So Husserl thought that any perception or any moment of intentional consciousness, to make it even a bit more general, consists of three things. A primal sensory impression, that's what our senses record about the environment. A retention of past impressions, and a protension, which is an anticipation, something like an anticipation of future experiences to come. And very importantly, this is a transcendental content. It's not an empirical generalization, and it's not a description of experience, but it's really what makes a certain form of experience, namely the experience that we have, intentional conscious experiences, possible in the first place. It defines the structure, how we experience the world. Specifically, Husserl was very interested in how those different parts or moments of time consciousness relate to each other, how they unfold over time. So, for example, Husserl believed that primal impressions of the past somehow become retentions that we have in the future, or that the protensions, meaning the anticipations that we have now, will be compared with future primal impressions. And depending on whether that fits or not, we have different phenomenological experiences, or we have different experiences. We might be surprised, or we might feel a certain sense of satisfaction, or a certain sense of, okay, it fits, and so on. So that was a very important part of this analysis of time consciousness. Okay, now I see that I probably should limit myself to one of those transitional models. And here I chose one from consciousness studies, namely the projective consciousness model, which was developed by David Rudrauf and Ken Williford and others. And here are some quotes, which I think are representative of this model. According to the projective consciousness model, the geometrical structure of multimodal lived conscious experience closely approximates a projective free space. So that's a structural and then a descriptive statement, right? We describe the content of some experience, but we describe it in a way that we appeal to a structural entity. In that case, the projective free space. But they also say something very interesting. They talk about point of views. They say the point of view or origin is elusive. It functions as an innermost zone around which experience is organized. One is tempted to read it as a descriptive statement, but if one does, it's not a statement about one particular kind of experience or one particular modality, but it's a statement which is typical for all, which should hold for all possible instances of experiences, or at least sensory experiences. It's about the form of experience as such. Or one could even go one step further and say, it's a transcendental requirement. To have an experience, an intentional experience, means to have an innermost zone around which this experience is organized. And that brings me to the transcendental examples. But before that, actually, there are two other transitional models which I just briefly want to mention. On the one hand, Don Hoffman's interface theory of perception, and on the other hand, Larissa Albantakis' work on animates, which is a very interesting offshoot actually from her IIT work, but I won't have time to discuss that in any detail. Now I want to come to the true or to genuine transcendental analyses that happen in phenomenology these days. And one is by Jeff Yoshimi and one is by myself. I start with Jeff's analysis. So I already mentioned something from his book, this idea with the house, with the visual essence of seeing a house, or the horizon analysis. There's another point that Jeff frequently emphasizes throughout his work, and I think that's a very interesting point that he makes, namely Husserl can be interpreted as what he calls a proto-dynamical systems theorist. So his descriptions fit very well on this picture, on this interpretation, fit very well to the framework, into the framework of dynamical systems theory. So here's one example on the screen that goes back to a Lithuanian US phenomenologist, Aaron Gurvich, who analyzed consciousness or described consciousness, instances of consciousness, with the concept of what he called a field. And in any field, in any conscious field, there are different motives which are co-present, or different parts. And some of those motives are more central and some of these motives are more peripheral. So for example, you might have an experience which would be described as having a central motive, writing a paper, and having three peripheral motives, being in a room, experiencing your body, and hearing bird sounds outside. Now in Gurvich's work, he was very interested in how these different motives change. So what motives become central and what motives become peripheral. So there was a dynamical aspect to that over times. So for example, the field that had writing a paper as a central motive might become a field where bird squawks are the central motive, and writing a paper becomes peripheral. So in the words of Jeff Yoshimi, one studies field transitions in the style of Aaron Gurvich. One can analogize that to a dynamical systems interpretation. So you have one state, a complex state, more or less complex, which evolves over time. So phenomenology actually studies on that picture, studies potential forms of transitions, of trajectories throughout this space. And interestingly, one can make an hypothesis and say, okay, this transition in protodynamical state space is analogous to what's happening in the brain. So when we study the neural correlates of consciousness, that's also best described by with dynamical systems theory as a set of state. In a sense, there is a set of state and a sense of clustering between states which evolves over time. So there might even be an isomorphism or a very strict or a very close relation between what's happening on the phenomenological side and what's happening on the brain side. In each instance, I think it's very important to emphasize that when you appeal to a state space, you already take this view that consciousness or experience, subjective experience, has something to do with a trajectory between through a space spanned by possible experiences. So consciousness, our actual conscious experience, has something to do with these trajectories. Okay, a second potential phenomenology, transcendental analysis in phenomenology relates to something that I worked on in the past. It's related to this notion of constitution, intentionality and time consciousness and various other kinds of typical phenomenological motives can be seen as different aspects of the constitution of our experiences, describing the genesis of a structured manifold corresponding to the phenomenal structure of consciousness. And a bit more concretely how that could be put to work in the context of neuroscience, mathematized phenomenology could do explanatory work that goes beyond describing explananda. So people often think, okay, phenomenology is just describing the targets that neuroscientists need to study somehow. And so phenomenology does the description and then we appeal to science to do the actual work. But I think that's not how it goes. I think phenomenology is able, or at least potentially, doing some explanatory work beyond what other scientists could be doing. And one way this could play out is by saying, okay, phenomenology describes top-level constraints on set of computational or neurocomputational processes that need to be orchestrated in a certain way to jointly lead to conscious experiences. Okay. Now, perfect timing. Okay, now I come to my last claim, which I call the methodological orthogonality claim. So if you remember this graph, there are these different placements, and one might argue about these placements. But there's another argument which one could have, namely about what is the right method that people should actually adopt when whatever they want to do here. And here I would say, okay, it does not really matter whether you subscribe to a transcendental approach or a purely descriptive approach. It does not really matter for this question whether you should do mathematization or computational modeling or empirical investigation or philosophy. And one example, a traditional example from the literature for that, is actually drawn not from Husserl, but from another phenomenologist, from Martin Heidegger. It's genetic phenomenology, which is the idea to study the history of experiential processes, how this history shapes future experiences. And you could do that in a purely descriptive way. There's a non-transcendental descriptive reading where you would stay in natural attitude. So you would say, okay, there's this objective process that happens in the world. You maybe describe its correlates, the correlates of context, affordances, norms of presenting. So phenomenologists would typically say to you something that whatever we experience is supercharged with all of these other things. It's not just sensory information, but it's a lot of other things. So like in the example of the house where we see more than hits our eyes, and they would say something like that. Now, in genetic phenomenology, one might try to look at behavior or behavioral changes on a breakdown of usual circumstances. That's very typical for our experience. So we learn to navigate a certain physical environment. For example, when the way is blocked, we learn how to circumvent this blocking. And that's typical for the way that shapes the way how we experience the world. And then we can use a lot of some empirical tools to further study that or to more precisely study that. For example, we could appeal to locomotion and gaze tracking or computational modeling, or maybe we like active inference, the free energy principle, and we try to use those things to model these things. And that's perfectly fine. That's a descriptive approach, but one could also do a transcendental reading of that. That would bracket the natural attitude. So it's really not about how these physical objects behave in space and time, but it's rather about the description of motivation, retention, protension, so these transcendental aspects that feature in our experience. So in other words, we study the necessary or a priori constraints on the unfolding of experience rather than the particular description of contingent behavioral trajectories. Or to put it in the words of Husserl, one would say we study the law-like sedimentation of habitual processes, where habitual processes just means things that we learn to do. So as we learn to walk along the house, we learn to go to the podium. And those habitual processes make one kind of experience possible. And importantly or interestingly, I think this transcendental reading could rely on the very same tools than the descriptive reading. And here's another example, a final example, that's my final slide, from the research that I'm currently doing, my own research. If you remember on the very first slide, I said something about what I take the fundamental problem of consciousness studies to be, is the relation between third-person data and first-personal perspective. And that's the guiding motive behind this kind of research. It's about embedding third-person data, so data from brains or AIs or maybe cells, with embedding in certain in spaces which I call experience spaces or phenomenal spaces, and then defining a network or defining relations between potential experiences, or remember this motif of potential and actual experiences on this space. And if you have that, you would define a certain structure, which I call a Q network. And here you can try to use mathematical tools and relate the things that you find in this Q network to typical phenomenological concepts. So for example, one thing one could study topological structure of such a network. Calculate what is known as the Betti numbers. Or one could do even a bit more sophisticated stuff in trying to model action systematically on that network, which I do with category theory. I won't go into the details, unfortunately, here. But the nice thing that relates very straightforwardly to what Husserl said, what we could do, what we should do, namely to study invariants or things that stay invariant and things that change under certain transformations, which are defined by our actions. With that, I'm coming to the end of my talk. I thank you very much for being here, and I'm looking very much forward to the discussion. Under this link, you can find this presentation if you want to go through it, or you can just write me an email. I would be happy to hear any thoughts or answer any questions. Thank you very much.